Okay, so for the title for today's presentation is going to be air mass notes. Let's write that across the top of the page in your notebook so that we can find it when we need it. First, some background information, just kind of summarize what we know about temperatures and all the things that determine a temperature's location. One, we know that the curvature of the Earth affects how much sunlight you get, how direct the sunlight is, which affects your temperature. You know that going around the sun at different times of the year, you get more or less sunlight. It's going to affect your temperature. We know that elevation, or being in the mountains versus being at sea level, makes a big difference as to what your temperature is going to be. We know that the west coast and the east coast and the center part of the country, even though they're at the same latitude, have distinctly different temperature patterns. And finally, we know that if you're in the downtown of a city, you're going to be hotter than in the areas in the countryside around it. We get it. We know this. But let's look at Atlanta here and think about all those variables. What day of the year it is, how much sunlight we're getting, that's due to what latitude we're at, elevation, and distance from water. All of those things combine to give us a certain temperature and temperature pattern throughout the year. But let's look at this situation here. And we researched this when we did our temperatures web quest. On January 22nd, 1943 at 7:03 a.m., the temperature was -4 in Spearfish, South Dakota. And 2 minutes later, the temperature was 45 degrees. That's a 49-degree change in 2 minutes. And that set a world record, which is still true to this day. Now, by 9 a.m., the temperature had gone all the way to 54 when suddenly some winds died down and the temperature went right back down to -4 degrees. A 58-degree drop in temperature only took 27 minutes. Now, I ask you, how could the temperature change so dramatically? If you think about all those variables that we know determine temperature, which one of those things could have changed so quickly? Another situation here, a difference of one day, Sunday at 2:30 to Monday at 2:30. You can see in Boston, Minnesota, it was 90 degrees on Sunday, and on Monday it was 39 degrees. So what changed? Their elevation certainly didn't change. You're not talking about a change of a season that dramatically in one day. Their latitude didn't change. So there's something else that determines temperatures that we haven't looked at yet. Here's a 5-day forecast for Atlanta, and you'll notice that we were at 70 degrees on Sunday, and by Tuesday, we were 45 degrees. We got distinctly cooler. Well, the seasons didn't change that quickly. Seasons don't change in, one day or 2 days. Our elevation hasn't changed. It's not like, we're changing our location, our latitude. We're not any closer to or further away from the water. So there's something else that helps to determine what temperatures are going to be. That is the topic of today's discussion. That is air masses. First of all, what is an air mass? Now, for this notes, anytime you see these numbered questions, you are going to write this in the notebook, and then you're going to consequently answer the question. These are the notes that you need. An air mass is basically a large chunk of air that is over one location. So think about this map of North America. Over Canada, they have Canadian air. It's a chunk of air sitting there over Canada. We're not breathing Canadian air. Consequently, down here over the Gulf of Mexico, there's a different set of air that's over the Gulf of Mexico. The air is over the land at that location. So an air mass is a chunk of air that is at a certain location. Now, how big are these air masses? Notice this is question number 2. When we describe the size of air masses, here's how we're going to describe it. Air masses are chunks of air that are the size of a few states. And this is a good representation. See, it's not the size of Atlanta. It's not even the size of Georgia. An air mass is the size of a few states. It's a big chunk of air. Now, how are air masses described? This is our third question. We're going to need a little bit of explanation here, a little bit more room in our notebook for this. Let me set this up for you. This air mass here up in Canada, you know what Canada is like. It's way far north. It's generally pretty cool because you're so far away from the equator, your sunlight is very spread out. Versus down here, close to the equator, it's going to be hot because you're getting a lot more concentrated sunlight. So you're going to have a very distinct difference between this chunk of air and that one. This one up here in Canada is going to be cold, and we know this one down here is going to be hot. So different air masses have different characteristics because of where they come from, because we know different places have different temperatures. Air masses are described by two variables, that is, their temperature and their water content. Those are the two characteristics that make an air mass what it is. Now, that gives us very distinct air masses because we know temperatures follow a very regular pattern. Like a certain place has a certain temperature pattern because of their proximity to water, their elevation, their insolation, latitude, the whole 9 yards. So we know what it's like up here in Canada. We know it's generally kind of cold, especially in this part of Canada where we're farther away from the water. We're going to change out. We're going to get cooler, or sometimes in the summertime maybe a little bit warmer. But we know that generally down here is where the hot air is going to be. So over Canada, we got a chunk of air that is generally cold because it's far from the equator. And over the Gulf of Mexico, we generally have a chunk of hot air. That's the temperature of these two air masses. Think about these two air masses. Now, notice they're both in red. They're both hot because they are both down south. But this one right here is over water versus this one here, which is over land. That's going to give you a distinctly different characteristic between those air masses. Here you can see two different air masses out the window of a plane. You can see that this air mass here, lots of clouds. Clouds are just water. And over here, there are no clouds. It's clear. This is a point where we get two different air masses that are meeting one another. Same thing here. No water in the air there, a dry chunk of air versus a wet chunk of air here. And there's that place where they meet. Now, describing and naming. Continental means land. It's an air mass that formed over land. Maritime is one that's over water. Polar means it's near the poles. That means it's cold. And tropical means that it's hot. These are the four words that we use to name air masses. Are they over land or water? And are they cold or are they hot? Those are the two characteristics that we use to name air masses. So we're not going to write out those words every time. We're going to use letters. The letter C is going to represent continental, so it's over land, and M represents maritime, or if it's over water. Then we use a different letter, an uppercase letter, to describe where is it coming from. T for tropical. Tropical meaning it's from someplace warm, and polar meaning that is from someplace cold. So look at these two air masses here. This air mass up here would be described as continental because it's over the land, but P for polar. It is a continental over land, but polar because it's cold air mass. This one down here, that is a maritime because it's over water, and it's a T for tropical because it's from a hot location. There they are written out. But we're not going to write out the words every time. We're going to use these abbreviations, but we have to know what the letters mean. This is a continental tropical versus a maritime tropical. One of them is going to be wet, and one of them is going to be dry. This one over here, because it's over water, is going to be a wet, and this is going to be a dry chunk of air, but they're both going to be hot. Now, there are 6 distinct air masses that affect the weather in North America. We're going to label these on this map. We're going to make a little chart underneath this map. Come and see me. When you get to this point in the presentation, I'm going to give you this map to put in your notebook so that we can then describe the air masses below it. The first one, number 1, right underneath your map, it is the Maritime Polar. And notice I put in parentheses Pacific because there are actually 2 Maritime Polars. There's an ocean over here and there's an ocean over here. And the difference is one's from the Atlantic Ocean and one's from the Pacific Ocean. Number 1 is the Maritime Polar Pacific. So it's a over water and it is a cold air mass. This is the air mass that gives Seattle its weather that it's so famous for. And that is it's kind of a cold, rainy, kind of dreary climate. Because that's the air that is coming to Seattle all the time. It's cold and it's got a lot of water in it, so it's kind of rainy. This is what that part of the country looks like. It's very typically misty. You can look at that picture, you kind of get like a damp feeling to it. You know, lots of moss covering all the trees, has a hard time drying out because they're always having cool, wet air. There's a joke in Seattle about the seasons, and that is fall, winter, spring, and summer. You notice in each one of them, it's raining. because they get a lot of rain there because they always have that wet air mass that is coming over them. If you want to go visit the Washington Rain Festival, notice that the joke with this is it is January 1st to December 21st, in other words, all year round, because it rains very frequently there because they always get that same air mass coming to them. So we're going to summarize this. Underneath that chart, we've got number one, we've got the Maritime Polar Pacific. Here are the characteristics that we want to make note of about that air mass. Number two is the Continental Polar. Continental Polar is coming down from Canada. It's continental, it's over land, and polar, it's cold. This is what the Continental Polar air mass looks like. Look at this area up here in the sky. We see no clouds. That means there's no water. That means this air mass is dry. But it's also very cold, which is exactly what that air mass is like. It's dry and it's cold. When that air mass comes to visit us in Georgia, that's when we get our cold weather. Notice this is on Centennial's campus, and we've got some frozen water over here on the rock wall by the bus ramp. It's normally not that cold here. It doesn't get that cold here in Georgia, except when that air mass comes to visit us from Canada. That air mass is the only reason why we ever have cold weather here in Georgia. That cold air mass, that continental polar air mass, can cover up the entire United States. That is the air mass that makes anybody cold in our country. And you'll notice, this is kind of a joke here, National I Hate Florida Day, because if you see on this map, Florida's not cold, because that continental polar air mass has a real hard time ever pushing that far south and making Florida cold, which is another reason why Florida seems to always kind of be warm, even in the wintertime. Another joke here in Florida is the weather forecast. Like you way up here in Georgia, we get that, oh, maybe it'll snow this year. Maybe that continental polar air mass will bring cold enough air to Georgia to get snow. 80% chance of sweaters only in the morning. Is it too chilly for the beach? What's a fireplace? Land of permanent flip-flops. Because that continental polar air mass has a very hard time ever coming all the way to Florida, so Florida never gets cold weather. Now, the continental polar, this is the summation. It's cold and dry. It affects all of the United States, especially east of the Rocky Mountains, and this is the only reason why we get cold in Georgia, is because of that air mass. Number three, the Maritime Polar, but now we're looking at this guy here. He's in the Atlantic as opposed to this guy, which was in the Pacific. This is what that Maritime Polar air mass looks like. Maritime, it's wet. Polar, it's cold. This is in Maine, and you can see how it's foggy and misty, but there's snow and ice on the ground. So this is cold, wet air. That's exactly what and I forgot to change this. This is the Maritime Polar air mass. It's cold and wet. It basically affects the northeastern United States like Boston, New York, New England. And this is why it snows so much up there, because they get cold, wet air. And that's an ingredient that you need in order to get snow. Now, the Maritime Tropical Pacific, this guy over here, number 6, is maritime because it's over the water, and it's tropical because it's down south. This is what gives California its very distinct climate. Now, in California, it's always sunny, very rarely rains, doesn't ever really get really hot or really cold. Even though you're pretty far south and it's sunny, it doesn't get hot because they have that maritime tropical air mass. Its characteristics, it's warm, certainly, because it's down south, but it's not very wet air. Because the water in the southern Pacific doesn't evaporate very easily because of its temperature, it's warm, but it doesn't have much water in it. And this is why California is always sunny and it doesn't get too hot, because it's kind of damp air, so it's never going to get really hot, but it's not enough water in it to give you rain. The Continental Tropical, number 5, this guy that's coming at us over Mexico. This is what it looks like. It is hot and it is dry. This is the air mass that makes the southwest United States, like Arizona, Texas, into a desert. This is why we have deserts in that part of the country, is because the air that's coming to them is both hot and dry, so they don't get much rain and they're always hot. That's the recipe for making a desert. Number 4, the Maritime Tropical Atlantic. This is the big guy that we're going to talk about a lot because this is the most active, most important air mass in our country, especially in our part of the country. Florida is swampy and wet and covered with water because of that maritime tropical air mass. That is the air mass that is parked right over here over both sides of Florida. So what's Florida like? Well, it's warm and it is wet. It's humid, it rains a lot, and it's always warm because they always have a warm, wet air mass parked right on top of them. This is what Louisiana looks like. You can look at this picture and see, okay, it's wet there, it's swampy, and that's obviously a hot location, and that's a direct result of that air mass. Georgia, we are primarily under the influence of that warm, wet air mass from the Gulf of Mexico. This is why we have so many trees here. This is why it rains so much here, because the air that comes to us is always warm and wet. That's why it's hot and humid for the most part here in Georgia, because that's the air that is coming to us. So that maritime tropical Atlantic, it is hot. Notice I'm going to use this. It is not just wet, but it is dripping wet. It is soaking wet. It's like a sponge that is dripping when you pull it out of the water. I can't emphasize to you enough that this is the wettest, most soaked air mass in North America. And this is why the South is hot and humid. And this is why we get rain in the eastern part of the United States. We don't have any deserts in the east because this air mass always comes and brings enough rain. Let's take a look at Texas, though. And Texas is a very unique case. Let's look at the air mass that influenced the climate there. So here I am in eastern Texas, and you can tell by the view behind me. Look at all of those trees and look how wet and swampy the ground is. This is a place that gets a lot of rainfall, and that's because here in East Texas they are primarily influenced by the maritime tropical air mass coming out of the Gulf of Mexico, which that maritime tropical air mass has a lot of moisture in it and creates a lot of rain, a lot of precipitation, which means a lot of trees grow and there's a lot of water on the ground. So once again, East Texas, where all they get is the maritime tropical, that warm and wet air mass out of the Gulf of Mexico. So this is what far west Texas looks like. And here, the only air mass that you get is that continental tropical air mass that comes out of Mexico over there, which means it's really, really hot and dry. They don't ever get any of that maritime tropical air mass coming out of the Gulf of Mexico with all that water to bring rain. So you can see in this area here, it's extremely dry because the only air mass they get is that hot and dry continental tropical air mass from Mexico. So East Texas over here can get this guy coming to town, which brings warm, wet air, get a lot of rain. But West Texas, for the most part, only gets that hot, dry air. So Texas as a state has kind of two extremes with what their climate is like because they're kind of right in between the two air masses. So what does Central Texas look like? Well, it's not as wet as East Texas. They got some trees and they've got some green, but it's not as dry a desert as we saw in West Texas. If you go a little bit further west than Central Texas, you're going to see this. Well, now there's no trees. Remember, trees are an indication of how much rain you get. I don't see any trees here. All I see are like kind of low-lying plants. There's still some green, but this is a place that obviously doesn't get as much rain, doesn't get enough rain to grow any trees. So at this point in the presentation, you should have an understanding of what all of the answers to all of these questions. You should have all of these in your notes. If you don't, you can ask a question or get clarification. These are all concepts that will be on the notes check that you're soon to take. Here's a second page of understanding. Do you have this information either in your head or on the page of your notebook? Now, the question becomes, how do these air masses move? How does air from Canada come to Georgia? How does air from the Gulf of Mexico push its way into Georgia and then further up the East Coast? Remember, it all has to do with that air pressure. Remember that air pressure is the pushing of air particles. Air can push on each other. And when you get a difference in pressure, remember that the air is going to push from the high pressure to the low pressure. So we get areas with different pressures, and that pushes air all the way around our country. And this is how air can move from Canada to Georgia. It also explains why air from Canada can't move to Florida. because by the time it gets that far south, it's run out of strength. It can't push any further. There's a limit as to how far south that air can push. But air pressure is the reason that air masses can move, why they don't stay over that one place. It's the end of the presentation. At this time, bring your notes to get a done stamp and pick up a copy of the notes check over this information.